Hey everybody, my name's Sherif. This is the Near 101 V0.4. It's the fourth time we've run this presentation. We have 3 recordings for you to take a look at. And actually, if you go to the URL, the bit.ly URL that's just there in the first post in the chat, you'll see that it's bit.ly / near 101. You'll see the slides that we're working off of. So that will remain there. I can see at least one other person has opened those slides. If you want to participate in some of the code along work, you're going to want to download Node. So may as well get that started now. Since this is something that we've run several times, I'd like to try something just a little bit different. It looks like there are about 15 people registered, but about 5 people that are with us, and I think about half of those folks are quite familiar with Near. So what I'd like to do is, maybe other people will join us as we kind of move into this. But what I'd like to do, given that we've recorded this event a couple of times now, is really just prioritize our time together. So so with that, I think it would be a good idea to actually step through some sort of list of what topics we want to cover. So I've got a couple of topics here. If you check out the slides, and I can go ahead and share my screen, but you'll see here I've got a couple of topics that we can cover, and of course I'm happy to dig into some other topics with you. But these are some of the things we can cover right now quite easily. So I'd like you to give a thought to some of these topics, because really there are a few recordings of the same presentation that you can check out. There's a hackathon that's coming up in just a couple of weeks here, a little bit less than a couple of weeks, and some bounties, some that are available now, some that'll be published soon. So there's quite a bit of opportunity if you're interested in Near to connect with the community and do some good work and get rewarded for that time and effort. And so maybe you've watched some of the recordings and you want to dig deeper into one topic or the other. Maybe there's something that we haven't covered in these that you want to dig into that you're curious about. So I just want to open it up to some discussion around that. And I guess hey Nikhil, welcome back. So I guess what we can do is just start just by using the chat here. We can make some suggestions. What do you want to spend time talking about? And this could also include if somebody wants to jump on to the screen to give a presentation or a demo of something they've done, if somebody wants to jump in and have a discussion about something related to either work they've done or something they've seen, wide open to that. We've got 90 minutes together on the calendar here. We have a bunch of stuff we can discuss. But I just want to open it up to you to help us prioritize our time together. So in the chat, let me know what we should talk about. Okay, nice. So Crass Kitty saying client-side code, Near API.js, and then the platform tools are fascinating, fantastic. So we can definitely cover that. Any other topics? Anything else that we want to dig into? Just give it a couple of minutes here. Looks like we've got about six folks right now. Anything else that you want to see, or anything else that you want to discuss? Or if you have something that you'd like to present, Nikhil, I know that you're quite active in the community. If there's something you're working on that you'd like to share as well, you're more than welcome to join the presentation and do that. Mike, I see you're here as well. If you're up for presenting something, or Josh, if you want to present something that you're working on, more than welcome to do that. Okay, great. Hey, Kelly, that's fantastic. Yeah, there's actually a poll here. Why don't we just ask? I think I've just made the poll visible here. If this is your first exposure to Near, if you're familiar with it already, so we can get a sense of who's there. Paul, that's great. How to store keys on the machine, deploy contracts, and call methods. Okay, awesome. Crass Kitty, out of deference to some of the folks that are new, if you don't mind, I'll just prioritize their requests here. Nice, thank you for understanding. We can defer to Kelly and Paul's requests for what to cover. Okay, so digging into contracts, and then while we're doing that, we can talk about Paul, we can talk about your request. Nikhil's asking about token issuance. So I think you mean, Nikhil, maybe like an ERC20 or 721 equivalent token. Is that what you mean? Nice. Okay. So we can take a look at some contracts that we have, actually some demos, and we can take a look at what it's like to deploy those and use those. Even take a look at the contract state, see what's under the hood. Okay, so I think why don't we just take this as a tentative agenda and see how this plays. And I'm just I can share my screen, I guess, while I'm doing this. Can you see? Yeah, looks like you can see that. Actually, it would be helpful for me to invite one other person to this conversation, so that we can so you can let me know if like I'm missing something in the chat and I need to jump over there, or if like my screen is too small or something like that. Crass Kitty, are you down for joining the call and helping kind of facilitate while I'm off screen? Awesome. Okay, let me just add you now. I think I just click on this button here. Let's see what happens. I assume you get invited, you got to test your mic or something, and then you jump into the call. Is that what happens? Yeah, looks like you're joining. The button's changed. All right, well.
Am I in?
Yeah, hi. Awesome, welcome. Yep. All right, so Ashley, I guess I'll just ask you the favor of monitoring the chat, and if there's something that I'm missing, or obviously like representing yourself. If I say something that doesn't make sense, or if I'm making some silly mistake, to just kind of shout it out, and that way there's two of us who are paying attention, and it's not just me kind of off in a la-la land here.
Oh.
Okay, so let's talk, and we can come back to the Rainbow Bridge at some point as well if we want to. Let's talk briefly about the demo application and how that's going to work. And I think before we do that, we can just kind of take a look at the tools here that we'll use to play with this. And I'm just going to walk right through this. Okay, so based on the questions that Kelly and Paul asked, digging into these contracts and then storing keys on the machine, we'll take a look at that. And then Nikhil, with any luck, I don't know, it's about 10 minutes after, probably within like 30 minutes, we'll be able to get to this. And then we'll have plenty of time for questions and follow-up, and unless something goes wrong and the demo gods aren't smiling on us today. So Create Near App is a Node tool that we use to generate code for a template application. The contract backend, you can think of it, and the front end code. And so the contracts in Near are executed as WebAssembly running in a virtual machine. And then we store the state of output of those contracts on chain. So to produce that WebAssembly, we have software development kits for AssemblyScript and for Rust. And you could imagine there could be other compiled languages that can build to that. We don't have that yet. If you're interested in that sort of thing, we're wide open to suggestions and help in that area. But right now, you choose AssemblyScript or Rust. AssemblyScript looks a lot like TypeScript if you squint. Looks like JavaScript, so it's pretty easy if you have any familiarity with JavaScript. And Rust, draws on Ruby, for example. So if you're familiar with that language, you'll notice a lot of similarities there. But it's a strongly typed language and very mature, rich tool set, very supportive community, and it's really the safety, the type safety of Rust and the safety of the language, the predictability of the behavior of the compiler when you're using Rust that leads us to say if your contract has a lot of value that it's controlling, then you want to use Rust. So for the safety of the behavior of your contract, the reliability of the behavior of your contract, Rust is your better bet for now as AssemblyScript continues to mature. But if you're coming from a JavaScript background, then there really isn't a faster way to get on board with Near than with AssemblyScript. And in terms of the kind of the choice and maybe the opportunity cost, they're interchangeable in many ways. A lot of the lessons that you'll learn when you're thinking about Near, how to design your contracts, how to get them to work together, making cross-contract calls, access to the environment, basically a lot of the mental models, the ways that you would think about building on Near are consistent across the two languages. So it's not it's not a big cost. You actually can benefit from entering in either direction. It's really just your choice. On the front end, oh yep, go ahead.
Are they interchangeable then? So like if you're building an AssemblyScript, can you just switch to Rust? Is that okay?
It depends on the details of your contract. For the most part, the answer is yes. Let's say maybe 70%. I don't know, just pulling that number out of thin air. But there are features that Rust has that the Rust SDK has that aren't available in AssemblyScript. For example, in Rust, you can mark a method as explicitly as payable. And if you don't do that, then the Rust SDK will add a little bit of code to basically reject if you accidentally attach money to your call. So that's similar to Ethereum, for example. So if you're coming from Solidity, there's a payable keyword that you attach to a function that says, I can attach money to my call to this function. And so Rust has that feature as a payable keyword. AssemblyScript doesn't. And so if you wanted to get that behavior in AssemblyScript, you'd have to write a little bit of code, 1 or 2 lines of code that would basically check to say if there's any if there are any tokens attached to this call, then and it's not supposed to be attached, then you've just made that decision as a developer basically. If it's not supposed to be attached, then reject it basically. And so instead of one keyword in AssemblyScript, in Rust, when you're writing it in AssemblyScript, you'd have to write maybe a couple of lines of code. So that's an example of some differences, and there are a handful of those. But more importantly, and this isn't necessarily something that you would see while you're developing, the Rust toolchain, the Rust compiler, type checking and type safety in Rust, and sort of the strict ways in which it handles data types means that the output is going to be safer to execute, is less likely to misbehave while the code is running. And so you're going to get a safer contract in Rust, basically more reliable. Until the AssemblyScript tooling matures and the language and community matures, Rust is many years old, AssemblyScript is much younger. Until that happens, you can't really kind of just switch between the two. So again, some things are going to be visible, like the payable keyword being in Rust but not in AssemblyScript, and then some things are going to be invisible or implicit as part of the toolchain reliability.
Thank you.
Mm-hmm. Yeah, but otherwise it's basically the same. So you're still building on Near, you're still thinking about Near, you're still thinking about accounts and contracts and how they work together. So in that sense, there's a lot of overlap, but there's definitely differences. All right, so this and Ash, thank you for interrupting, by the way. Feel free to continue to do that, so we can just keep the conversation going. If my answer isn't satisfying, we can invite someone else who's on the call to join and give it a shot. Maybe they have a better explanation or a different explanation. So I'm always down for being interrupted by you, and if you notice anybody in the chat who's asking something.
I'll definitely bring those up to you. Thank you.
Perfect. Yeah, thank you. Okay, so anyway, so here's create near app. It's just a tool. We're going to use this to generate some code, and then we'll take a look at it. And I'm just going to stick with the vanilla stuff so that we don't bother with React for now. I'm going to stick with vanilla, and I'll just generate 2 projects, one in Rust and one in AssemblyScript, and we can run them and compare them and kind of kick the tires. Okay, so let's just do that here. So npx create near app, and let's say let's call it a rusty banana for the Rust version, and by default it's AssemblyScript, so I'll just say the contract is in Rust. How's the sizing on the screen, Ashley? Can you see it okay? Okay. All right, sweet. So while that runs up there, I'll just do another one down here, and I'll remove this extra switch. Please don't be confused. I'm just trying to save a couple of seconds here. And this will be like a plain banana, like plain vanilla banana, I guess, vanilla banana.
Well, can you scroll back up real fast, just because I was trying to copy your rusty banana?
You mean this line here? Let me just paste that right into the
Sure.
The chat here.
And you don't need to put npx at the end of it? No.
So npx is the node utility that is basically like executes a package from npm instead of downloading it first to your local machine. So you can npm install create near app, but I'm not doing that. I'm just running. I'm saying npx, go get this utility from npm, run it for me, passing it the name of the project and these configuration switches, and so I can even do this. I can do npx create near app and just pass it nothing, and it'll by default, like you see how it's fetching this thing. It does it every time. It's been annoying, but so you'll save these 5 seconds if you install it locally. Okay, that's basically the cost of not installing it. It's not really a big deal. There's no trade-off here. I'm just doing it so that if somebody just wants to run this thing, you've got Node. This is literally the fastest way to get exactly the same behavior that I'm getting. But it's not a big deal. You can also install it locally. Anyway, if you run it with nothing, what you get is the automated help. Okay.
Got it.
And so this will show you can check the version, you can choose the front end, and it defaults to vanilla JavaScript. You can choose the contract language, it defaults to AssemblyScript, right? You can also show the help, which just prints this message, and that's also what comes out by default, okay? So I've made this Rusty Banana project. I can cd into the Rusty Banana, and then I have this tree command that lets me print out the files in the file system. And I'm just ignoring node modules because it's filled with a bunch of dependencies. So I don't want to, it's just very noisy if I don't ignore this folder. And so this is the stuff that we give you when you run this create near app. And so you've got a README for the project, that's fine. You've got some configuration for unit testing, the contract here, and in fact this is a Rust contract, so I would say these 2 files don't need to be here because they're for AssemblyScript. So let's ignore those. And so in the contract, you've got what a Rust developer would recognize as a simple Rust project with kind of a build automation script here that lets us do some compiling and pass in some switches, dependency configuration, output folder, and then the source files, this one lib.rs. Then you've got this folder near dev, which is the development folder that holds your keys. So to Paul's question, this is one place where your keys might live from a development perspective, and I'll show you the other one in just a minute. Package.json standard configuration file for node projects. The source folder has the front end, which is this web page, and then some JavaScript files, and we can take a look at those. And then this is for npm for the yarn lock file. Basically, freezing your dependencies is what this yarn lock is. To say if you want to pass this to somebody else, they will get exactly the same installation of all the other files that this project depends on, all the same versions, etc. Okay, so just standard node stuff. So that's what the folder looks like for Rust. Let's take a look at the same folder for assembly script, and in this case, README, we are using assembly script, so these files are relevant here. Instead of the contract folder, we've got this folder that contains the assembly script. Here's the main file. Excuse me. Here's the main file right there. And then we've got unit tests for that file. In Rust, you didn't notice the tests because the unit tests are built into the Rust file itself. It's just the way they handle unit tests. But in assembly script, we're using this what's called aspect, and it's an RSpec style unit testing library for assembly script, basically. And then again, the same bunch of accounts, the same standard node project, and then pixel for pixel, whatever, bit for bit, character for character, the same front end. So there's no difference there when we talk about this.
Ask if anybody else is having this issue, and if not, we can bounce past it. But when I type tree/I node_modules, it says no command found tree. Is that normal?
Yeah, it's totally normal. If you type, if you're on a Unix-based system, on a Mac, and you type the which command and then any other command, and it returns nothing. So if I have try trees, it'll say trees not found, But if I have the tree command, then it'll show me where it is. So you can check to see if you have the command. If you don't have it, you can use brew. I'm not sure if you have homebrew, but you can do brew install tree. That's the fastest way to get it. And you'll basically be installing this this file here. And tree just does that really nice. You see how long it is when I don't ignore the node files. Just a really nice view of your file system like that. Okay, so brew install tree will do it. Yeah, no worries. Okay, so definitely just keep asking questions, Ash, and if for some reason just let me push back if it's not the right time or if it's too big an issue. Okay, just be selfish when you're asking for help, and let me manage the time we've got. It's perfect.
Sounds good.
All right, so here is the file system, and I guess it'll probably be faster to look at the Rust first, although the code itself might be unfamiliar to you if you haven't written any Rust before. But let's take a look at it. I mean, no fear. Let's see what happens. So here. You can see there's quite a bit of documentation explaining what's going on. You can take a look at the software development kit for Rust. It's here, and it's all open source. There's quite a bit of documentation there to help you get your head around it. And if we open this up, actually, we can see. That this is the near SDK for Rust. We can see there's documentation here at the top level, and then here's the payable method. You kind of decorate a method like that with payable. So that's what I mentioned earlier. But you can see the documentation is right there, and then there's a rich list of examples here, and we use these examples to exercise the SDK to make sure that it's behaving the way that we want it to. So you can consider these contracts as basically complete feature coverage of the capabilities of the Rust SDK in near. If you can do it with the SDK, then it's being done somewhere in these examples. That's the way to think about that. All right, so then this front matter here is basically saying, we're going to use this custom serializer to put stuff on chain. I think this is a memory management thing for memory efficiency, but I'm not really sure. We want access to some features, including the environment and the ability to tag specific structs in our contract here so that they are exposed as contracts. We want to use a map as a data structure that we're going to serialize along with our contract. And then this is the memory bit that we manage here, and here you can see this is our near bindgen is what we're the attribute that we add to this top level struct, which becomes basically the interface for the contract itself. And this as a struct is just the definition of the data structure and its members. And so this struct welcome has a hash map whose name is records that we can refer to, and it just maps a string to a string. You can think of it like a phone book. You've got names and phone numbers or something like that, and we'll decide decide what data we want to put in there later. It's just a collection of records. That's all we know now, just reading from the top. And then the implementation of this, so again, this is just Rust. The implementation of this exposes two public functions, one called setGreeting and one called getGreeting. SetGreeting is going to mutate some aspect of itself, of the welcome struct. So we're going to mutate some aspect, and we're also taking in a message, which is a string. And the way this function works is it basically grabs the account ID, the signer account ID from the environment, spits out a log with some details about the message and the account ID, and so we can save that in the logs and inspect those logs if we want, and then inserts that record into the records hash map, basically. That's part of us, part of ourselves. We just insert that, and it's the key is the account ID, and the value is the message. So that's the string to string. It's like the name of the person who called this method, called this contract, and then the string that they passed in. And then when the other public methods to get the greeting, we're not mutating ourselves, but we do want to know who you are, because for this particular contract, apparently, we're going to match on who you are. And if we find a greeting, if there is some value that represents the greeting, then we'll give that to you. And if we don't find that you have saved a greeting before, if you're signing in for the first time in this application, then we'll just return hello. So that's how this, if there's nothing found, then we'll just return hello. That's how this code works. And then here's the unit test for that. We've got this mock blockchain that we're loading. There's some context that we can set up, including like demo accounts and things like that. And then we just exercise some of these functions. So this is just unit testing in Rust, pretty standard for Rust developers. If you're not familiar with Rust, some of this stuff can seem a bit disorienting probably. So that's the Rust contract. But before we do anything else with this, I want to try and open up the assembly script contract and see if that now that we've gone through the Rust side, if that looks familiar to you. So check it out. Here's the same front matter explaining how this thing works. We pull in some imports from the near SDK, this time ending in AS for assembly script. And we set a global default message. Notice there's no kind of global class or global struct or anything like that. It's just that this entire file represents the contract. And so we just export functions in assembly script. And so here's a function getGreeting and setGreeting. So we can let's just change the order of these so that they're similar to what they were before. So here's setGreeting at the top. We take in a message and then we grab the sender, whoever you are from the account. We log it out to the logging mechanism in near. It's basically just an array of bytes that is returned by the runtime to your calling context. And we can see that on the client side at some point if you want. You actually see the log in the browser console. And then storage, here we don't have a hash map or anything like that in this, although we could. We don't do that because the near native storage is actually a key value pair. So we're using that just by default, and we're saying set a record where the account ID is the key and the value is the message. And you probably recognize this. It's actually quite close to this line right here where we insert into the hash map the account ID and the message. And so that's what we're doing in assembly script. It's almost the same, and maybe this kind of answers the question a little bit that you were talking about earlier, Ash, is that it's actually quite close. There's a lot of the same thinking, a lot of the same ideas. There's this kind of sender in the context. You can log things. You can read and write to storage. And then getGreeting here, we take an account ID, may return a string or null in this case. And so we go and we get looking for this account ID and then give it the default message if we don't find that account ID. And so the way this contract works is if you've ever saved a message before, you'll get that message because we look it up in the map. And if you've never saved a message, we just give you the default message, which is defined up here. Okay, so pretty simple in terms of scope, but there's a lot going on, a lot of moving parts. If you've never written anything for blockchain, on Ethereum, this may seem a little bit disorienting to you, but if you've built any application before in a Web 2 world where you're using a database and a backend, you can think of this as your database, except it's slower and more expensive because you get the guarantees of it's cryptographically verifiable that this message was written by you, the possessor of this private key that is impossible to guess or brute force figure out in a reasonable amount of time. It would take you a very long time. So it's cryptographically secure. It's permanent for forever and ever, as long as this network remains alive. And it's likely that the network will remain alive because it's decentralized, which means unassailable. No government can kind of shut it off because it runs on distributed nodes that are operating independent of each other. And you can trust the data in this as long as some conditions are met. In terms of the number of people that are involved, something like 1/3 plus 1, and this in terms of the consensus model for proof of stake on Near. I can certainly do some more reading there, but we have a white paper published on it, and several documents, explainers that if you're interested in those details, you can dig into it. But maybe in the same way that you don't spend a lot of time thinking about the data model behind a database index, whether it's a B tree or whatever it is, you just write your data to a database. In this case, you can just write your data to the chain without worrying about the consensus model, trusting that the network is well behaved and doing what it's supposed to be doing, which is keeping your data integrity intact for forever and ever. Okay, so that's Rust versus assembly script, and I think that probably covers kind of half of what you were thinking when you were asking about this. I'm sorry, I've forgotten your name.
Kelly, I think it was Kelly.
Kelly. Okay, thank you. And so the other half of this is, well, that's fine, but how do I actually use it? And so we could dig into that. It's been about 20 minutes so far. So why don't we dig into that while we also talk about these keys and deploying contracts and calling methods, because it's kind of part of the same conversation. So and again, Ash, just asking you to help me out if there's any interruptions or any questions or any comments. Just let me know. In fact, why don't I just take a quick break and come back to the session here. Any questions, any comments, anything else that we want to dig into? Anything else here? Let me just make this poll. How's the pace? 30 minutes check-in. How are we doing? Is this okay? Should we speed up a little bit? Should we stay on track? I'm wide open to feedback. I just want to be clear about that. I won't take it personally if you think it's too fast or too slow. I'm really just trying to make sure this is the best use of your time.
I think you're doing great. I can't speak for everyone, but I think you're doing great. My only delay was installing Homebrew, so then I caught up pretty fast though, so that was it.
Beauty. All right. So yeah, it looks like we're fine. Okay, let's just keep going. Then looks like the poll is indicating we're doing good. Let me just share my screen again. It might be worthwhile to dive into some of these slides for just 5 minutes to set some context before we go to the front end here. So we just use create near app, and let me just make this full screen. And so these are the differences in terms of the file structures. You can scan these lists. I'm not going to read this to you, but you can scan these lists and get a sense of like the different files that are being used for this. And again, it looks like we've got a bit of cruft here in the Rust side. We don't need the aspect config and the asconfig.js in the Rust project. So you can see that they're actually quite similar, the folder structure here. And this is a basic starter. It's like create React app, just kind of gets you started. And so this is what we just did. There's some scripts in here. We ran yarn dev, or we will in a second, excuse me, to kind of get this thing started and actually play with the application. And then this is what we'll see. Welcome to Near. We can sign into the wallet, and then we'll change the message, maybe from hello to hi. And you'll see this little toast on the bottom right pop up. And then if you want, we can dig into some of these questions here, and so let's get back to that after we've looked at it. Pros and cons for assembly script in Rust. It's easier to prototype in assembly script typically, especially if you're coming from JS or JavaScript or TypeScript. And the challenge there is that it's not as mature. So you could say like the compiler is not as stable. The ecosystem needs a little bit more time to build up. But there's a lot of people who are interested in AssemblyScript. A lot of companies leaning into it, and there's actually an interest group that. A working group that Willem Wyndham runs out of NEAR, and so if you want to join that, you can ask us about it and point you to it. You're welcome to dive into that. That's where they really like dig into the maturity of the language and kind of plans for the features in the language they're going to add and stuff like that. I think they meet once a month. And then
it's on the near.org/events site, by the way, for anybody who wants it.
Beauty. Thanks, Ash.
You're welcome.
Okay, so on the Rust side, as we said, it's a more mature language, better ecosystem, compiler's more mature, and so you're going to get more robust contracts out of this that you can trust with more value, you're far less likely to get unexpected behavior. Of course, you still need to audit your contracts if they're going to hold a lot of value, and probably multiple audits. You want to kick the tires on them quite a bit, but because of the mature tooling in Rust and the maturity of the ecosystem there, you're likely to get a safer contract, a safer behavior, more predictable behavior. And that's really the key when you're talking about something that's going to be managing a lot of value, in perpetuity, I guess, unless you upgrade it. Okay, so that's that bit. Let's talk about some of the dynamics of contracts, account, and state here before we dive into this. And I think maybe I can start right here with that. And so these concepts are going to be useful to kind of get into your head as we dive into this. So when we make NEAR accounts, if you've seen Ethereum or you're coming from Ethereum, your account is the public key of a public-private key pair. And you make that account, and then you can interact with it, deploy a contract to it. People can send you money. And so in NEAR, accounts have actually rolled in Ethereum name services. So it's the ENS baked in at the protocol level. And if you don't know what I mean by that, it's like websites where you have Google.com, and then you can add anything you want before the Google, gmail.google.com, for example, and Google controls everything to the left of that Google.com name. And so with your account name at the top level, it might be ash.testnet, and so if Ash wants to deploy a contract, you can deploy a contract to say v1.ash.testnet or v2.ash.testnet. Those would be, say, two different versions of the same contract, or whatever it is she wants to deploy to those. But actually, accounts for human beings and for contracts are one and the same. There's no difference. So you can make an account, and then it's up to you to deploy a contract to that account or not. You can have an account that represents a user or a contract, or both, actually. So I can have my account, and then I can deploy a contract to my account, and then deploy a different contract to my account, as long as I've got the rights to do that. And the rights to do that come from keys. Accounts support two kinds of keys today, but it's basically a type that could be extended in the future through governance. But today it's full access keys or function call access keys. Full access keys give you keys of the kingdom. You can do anything you want with the account. And function call access keys are scoped to methods with an attached budget that you spend from while you're calling those functions. And so they're limited in budget and what they can do. And you can have an unlimited number of these two types of keys on your account. So your account, you can add keys to it, one of these two types. You can deploy a contract or not to an account, and then the account tracks its own storage and pays for the storage by staking, by basically locking up some tokens that are proportional to the amount of data that you're staking. So all of that I'm talking about is an account. That's the concept of an account, and then that account would live on one shard a shard being, this. You can think of it like the limited view of the blockchain as seen by one computer that is following that chunk chain, we call it. And these words can turn into word salad after a while, but to get the picture in your head, the accounts, the name, all the keys, the data that's associated with them, that's all one thing that lives in one place. We call that place a shard in Near. And then, although today mainnet is single sharded, in the future when it has many shards, then the protocol will redistribute these accounts across the shards to maintain kind of a healthy load, so that if you suddenly get a popular application like CryptoKitties or something like that that starts clogging up a shard, you can just move that account to its own shard, so that it's kind of limited by itself, while all the other accounts, which are just operating normally, can continue to operate normally without getting blocked by that. And so what you get is kind of this parallel movement of the chain that gets reconciled by some mechanism. I think we call it a finality gadget.
So for the sharding aspect, if we're like taking something like CryptoKitties and we move it to its own shard, would it then still have like clogging on that shard, or like how would that be prevented?
Yeah, no, I don't think you can prevent it. So in the end, there's an upper bound to how much you can get done in the amount of time that you're given to do it. And my understanding is that when you're building something like a blockchain, there's this trade-off you want to make between kind of I think the word is liveness, how responsive and sort of kind of quickly the chain does things like processing transactions, finalizing those transactions, and kind of moving forward through time. That's sort of one thing that you trade off. And then the other thing that you sort of trade that off versus like the amount of stuff that you can get done. And so you put these upper bounds, and I think right now you can get something like 200 transactions per second on a single shard in Near for kind of the simplest possible transaction. So that's the upper bound, probably lower than that. So if you get an account with a contract on it that's doing a ton of work and is pushing that upper limit, 100 transactions per second, 150, whatever the number is, then by the way that the protocol is designed, you're not going to get any faster than that. So you would take that account, kind of put it on its own shard, but it would just be limited to that ceiling. How would you fix that? My understanding is you would need to re-architect or kind of formulate the way the application's built. So you could build it so that those transactions that are high frequency, happening a lot, are actually distributed across several accounts. So you might have something like again, I'm out of my comfort zone here, but something like a load balancer that would take in the request to do the thing that you do very, very often and delegate it to another account through a cross-contract call. Say, okay, you take care of this, now you take care of this, now you take care of this. I don't know, maybe that's totally unreasonable because it's incredibly expensive to try and implement something like that on chain. But yeah, I don't know, Ash. I don't know if this answer is useful or meaningful.
I just was curious, so you helped. Thank you.
Okay, nice. Yeah, so bottom line is when you say accounts on Near, it is this name, and it can have kind of sub names to it. Each one of those would be their own account, but the account has a name, it's human readable, it has keys, it has data, it may or may not have a contract on it, and so that concept is going to be key. When we talk about transactions, we're talking about a list of 8 actions that you compose to make an action, and then you send it to the network, signing it if it's going to change state. And then internally what happens is that turns into something called a receipt and gets passed around, including potentially resulting in transactions that get sent to other accounts in these cross-contract calls, which is kind of the key scalability mechanism in Near, because you're basically breaking up contract calls into multiple calls, multiple asynchronous calls that get distributed across accounts. So when you talk about a transaction, it's these 8 supported actions. What are these actions? They're going to be things like add a key, create an account, delete an account, send tokens, deploy contract, call function. So there's 8 of those, and they're at this link. And so you would have one or more of those composed into a transaction that you then send to the network, and it gets the work done. And then in terms of state, that's this key value store that we were just playing with, and we talked about storage staking earlier. This is kind of the shape of the thing, and so your dApp would be on the left, using near API JS in the top left there to send and receive over RPC to the blockchain layer, which then spins up your contract code in the runtime layer into a virtual machine. It does its thing, reads and writes to storage, and then sends the result back to you, which you get on the client side near API JS in your code. You get that as a result to your function call. And then
a question.
Yeah.
Sorry.
No worries. Yeah.
Who should he ask to help with an error appeared on the build time?
Oh, okay. So you're having some kind of error as you're trying to build the example with near with the NPX. Is that what happened with create near app? Okay. So it's going to be difficult to debug effectively on a group call like this, Paul. What I would suggest is the fastest thing you could do would be to meet on Discord, as Mike's suggesting, and you'll find a lot of people there to help you out. So Mike, if you're down for jumping over there and you want to coordinate with Paul, that would be great. But if you can't, if you don't want to miss out on this, nice. Okay. If you don't want to miss out on this, you want to do it later, that's fine too. I think Mike's offering just in case you want to kind of get rocking and rolling. And again, don't worry about missing this work because it's recorded, so you can always watch whatever you've missed. I'll let you guys sort that out. All right, so here's the structure, what it looks like. You build your contracts using assembly script or Rust near SDK AS or RS, and then you deploy it to the runtime layer. So zooming in on storage, you've got this metadata, which is the account information, how many tokens it's got, if you've locked anything because it's proof of stake. The code hash will be basically a fingerprint that's all ones if you don't have a contract deployed, or some other hash of the contract code that you can use to check if the proper contract has been deployed, for example. And then some other details about the environment, block height and stuff. So that's like your metadata. And then you have data, which is these key value pairs that are base 64 hash, the keys and the values. Okay, so that's basically what the storage looks like. And so here it is, kind of unencoded, from base 64. Rust contracts will have a key called state that includes the contract code, like the one that we just had now. Assembly script contracts don't have that, although that's a feature we're considering adding. And this is basically the contract code with its serialized state. And then whatever else, like the message, for example, hello world or something like that. And then if you have, other kinds of data, you might see these other kinds of things. Okay. So about 15 minutes or so on that. Just before we deploy this thing. So let's do this. Let's run what we need to actually make this thing work. And so in package JSON, if you forget what we need to do, you can kind of read through these. If you're not familiar with Node projects, this is basically the list of commands, that convenience commands that are baked into the project. So you don't have to remember to type all this. You can just type yarn dev and you get the benefit of this. Okay, but I could just as easily type this or any part of it that works. So this is going to run nodemon, a monitor that watches the assembly folder, and then if there's anything that happens, it's going to execute npm run start. By anything happens means if I change the contract, it's going to rerun npm run start, and then npm run start is going to spit out to the console the app starting, automatically open in your browser, and then this is kind of a cross-platform, Windows, Linux, Mac way to invoke a command that loads some environment files here telling us which temporary development account we're using, and then parcel we use to start a local web server, which we then load and automatically open in the browser. And there's also this pre-start, which is going to, this is a node-specific thing. So if you have start, pre-start is a special thing that automatically happens before start happens, which is to build the contract using this debug bit, and then deploy the contract. And these are up here. There's deploy, dev deploy, and there's the build contract. And so you can see these things are kind of chained. So when I run dev, I'm actually running start, pre-start, build contract, and deploy, dev deploy contract, etc. Right? So these things are kind of cascading like that. If it's a bit confusing, feel free to ask for some clarification, but it's pretty standard in the Node world to do this. All right, so we're just going to go ahead and run this. Which one do we want to run, the Rust one or the assembly script one? It doesn't make a difference in terms of the behavior of the system. It's just a question of whether or not we want to see one process or the other. The Rust side will take maybe 10, 20 seconds longer to compile the contract. Any preference?
I'll wait for a chat to respond and see if anybody responds. Rust.
Yeah, Rust. Okay, yeah. So yarn dev, and let's see what that looks like. It's the same command for both. So here you can see we're starting nodemon, and then we run through, and just to keep me honest, let me open up the Rust package JSON to see what yarn dev looks like there. So this is npm start, and then start is running this dev account parcel, and then the build here is going to be a little bit different. It's running contract build, and that contract build is going to here actually use the Rust tools to compile any dependencies that you've got, finish that compilation, and then yeah, it looks like it's still compiling. Did it get stuck? Let me try it again. All right, so the assembly script compiler is a simpler machine. It's going to go faster. The output is smaller. So that's kind of the difference here when you're building these things. Okay, so there it is, up and running, and automatically opens. Can you see this, Ash? Hello, rando.testnet?
Yes.
Okay, so let me just sign out. So this is what you see when you first log in, and you can see there's a little bit of front matter here that kind of tells you, hey, this is what's going on. So this is the demo. You click sign in. You'll see exactly the same thing on your computer.
So
and then when, what's that?
Forgot wants to know if it takes a lot of time for every small change in code.
Yeah, I mean, there is like an incremental build in Rust. You can do something with the compiler switch to reuse files that are compiled, like dependencies that are compiled and left in the cache. So that should speed up your build time significantly, so that it's down by a factor of 10 or more. And then if you end up running into something that's kind of buggy or whatever, you can always just kind of clear the cache and recompile again. So there's ways to make that process faster. It's just this is just like Rust development conversation. It has nothing to do with Near at that point. It's just Rust tooling.
Thank you.
Okay. Yeah. Okay. So here I've got my Near wallet. If you haven't signed into the wallet yet, if you haven't done this before, you'll end up with something that looks like this. So you may see this. If you've never created an account on Near before, it'll look like this. And so you want to create an account, and then pick a name for yourself, whatever that might be. And then actually these names will get stored inside of your local storage. So I've just opened up the developer console, and you'll see them in here. So I can show you over on this side. I've got in my local storage, I've got Sherif.testnet, rando.testnet, Sherif demo test2.testnet. So all these keys are here, and these are actually the private keys that I've got for these accounts, like just sitting right here in my local storage. Because local storage is scoped to this domain, this is secure. And you can also copy these keys out and move them around. So partly to answer your question, Paul, about where keys are stored, in the web wallet that we have, the keys are stored in local storage. Just whenever you log in, you'll see them there. Okay, and so I can go ahead and allow access to this application. That'll log me in, and here I am back. You can see sign out. That changes a little bit. The contents on the page change a little bit, explaining the different files, what I can do here with these files. Jump to the docs. There's other example apps, and then I've got this greeting, and I can say change this. The word save shows up. I click save there. That gets written to the chain. I get this little toast down here that says it just happened. And if you look at my status bar in the bottom left, you'll see this is actually a link to the Explorer. Ash, back to your question about some of the different tools. And so here I can go to explorer.testnet accounts for this dev account that's basically a timestamp. That's why it's a funny name like this. It was auto-generated by the build script to make it easier for me to develop with. So this is where the contract is deployed. It's given 500 nearby a faucet, and it's storing a little bit of data, so that's being staked in rent. And as this thing loads here, we should see any transactions that have happened, including the transaction that just happened a minute ago, where I stored passed in the word hello and got this hello world and got this other output.
I don't know if testnet or the Explorer is crashing right now. I'm trying to run the app and it's crashing for me on my thing, but I'm just giving you a heads up.
Oh, yeah, no worries. I mean, it's possible, that testnet might be a little bit sluggish or something like that. These are things that we're working on and getting better at. So we can give it a couple seconds more. If it doesn't show up, that's fine. We can always come back to it. So it just depends on what's going on. Sometimes there's an application that's gotten a little hot using the testnet or whatever it is. So anyway, looks like it's not responding right now. That's no big deal. So So anyway, what we would have seen is this text being stored on chain under this account. Sorry, not rando.testnet, but under the account for the contract, which as you see here is the contract that we're deploying to. So this dev contract, and so I can do this. I'm trying to copy this, but oh, there it is. I can do this here and say, I have the near CLI, and so I can run near keys for this account, and I'll see there's a public key. It's a full access key that's been used once as I'm logging in. Let's just leave this there. Okay, so you can see that nonce. Let's go back over here and I wonder if can we get it to use again, to sign again. I don't think so, not with this application, because well, let's see if we change this. I guess we have to sign it. Let's change it back to hello. See if that gives us the behavior we're expecting. So what happens now with the key? Used once. So it must be because I'm misunderstanding how this nonce is incremented on the key. I think we would need to sign another transaction, something that involves sending money to get that nonce to increment. So okay, so that's the demo of this application, and then if we wanted to, we could come into the contract code here and look at that, change it. We've already had a peek at that before. Or we could do the bit that we haven't looked at, which is the front end. And so here's the front end of the application, and just kind of picking this apart. The index is going to include some JS files. So there's index.js, and then this file is going to include some other bits. So this index.js is actually pulling in some utilities that have been used to kind of configure near. This is like the reusable bit, the utilities. And then specific to this application, we get the configuration of the network. You can see what that looks like in config.js. It's basically like all the endpoints here that we have for mainnet, testnet, and so on. This is basically how do you find near on the interwebs. And then and so that's what the config is. We pull out the network ID. And then the rest of this is just about like attaching to the screen the HTML. And so like when we submit the form, what do we want to do there? We want to, call set greeting, passing in the message. If something goes wrong, we want to catch that, disable the button, and then, get the greeting again, and basically, check to see that that this notification shows up to kind of show the toast, and then hide it. Whatever this is, 11 seconds later. So this is all just manipulating the screen. This has nothing to do with near. This is just web development. So just to give you a sense, the only near specific bit is that we have this contract object here with the get greeting method. I'll remind you that this was actually the name of the method get greeting right here that's on the contract. Is the same as this method right here. And then the question is, how did we make this contract object? Where did this come from? You can see here's the name parameters, account ID, and so that's what it's taking in there, account ID. This self here is an implicit bit in Rust, like in Python they do that as well. And so here we're passing in these name parameters to the contract, but the question is, where did contract come from? So again, the rest of the stuff is just HTML. Here's a near specific, this wallet connection. We can check if the user signed in, or if we want them to sign in, sign out. So let's look at this contract piece and see where this is coming from. So the contract is on the window object. If we go into utils and we see what's going on here, it's an implicit bit that's being passed when we call init contract. So just back to this file here, you see we're passing in init contract, and then we actually invoke this. When we invoke init contract, then it calls this function here that we just pulled in. And this function connects to near, sets up the wallet connection, gets the account ID, and then sets up the methods for the contract. This is where that contract object is coming from. So as you know from web development, Windows is a global object, so anything you attach to that shows up everywhere in your application in JavaScript. And then we're attaching this new contract object. We pass it the wallet connection and the contract name, and then view methods and change methods, where view methods are methods that read from chain, and change methods read and write. So they might actually alter the state of the chain. And we have to distinguish these here because underlying this bit here in the implementation of the contract object, there's a difference as to, view methods don't need to be signed, whereas change methods do because they change state. Okay, and so here just a little bit more of this kind of plumbing for logging in, logging out, and this is the method that redirects you to the wallet. So when you, with a wallet connection, request sign in, that's what actually handles the browser redirect. So this is the front-end code. If you're familiar with JavaScript, this should be pretty straightforward. But let me just stop here just in case it's not. Any questions or comments about this? Any questions or comments?
Not for me. Scott says he's all good.
Okay, nice. Just another quick poll here, 60 minutes. I just made the poll visible. How's the pace? Is this okay? Too fast? Too slow? Are we doing all right? Please don't try and make me feel good. Just be selfish about it. What do you need? We've got half an hour left together. We can even go over just a few minutes if we need to. How are we doing on the pace? Is this useful? Okay. So it seems like we're okay so far. All right, well, let's just keep going. Ash, if you can see I don't know if you can see the results of that poll or not.
Yeah, it looks like everybody voted on 16 minutes. Just right, stay on track. We got 4 votes for that. No other votes.
Yeah, perfect. Yeah. Okay. So we're good to go then. All right. So then the question is what else to cover? Token issuance was a piece that we wanted to discuss. I'm not sure if we're going to have the time that we need to do that, but I can pass you to the near example near examples repo, and this link here will filter the GitHub repo for you to show you a couple of different contracts. Okay, so NFTs is the fungible token standard implemented on Near, and so that's this one. For NFTs, FTs is the NFTs is non-fungible, FTs is fungible. That's this one. And then the last one that I'll call your attention to is the ERC20 to NEP21, and that's a demonstration that's in progress for the Rainbow Bridge that we're theming a hackathon around in the next couple of weeks here. And basically, it's the idea is that you would connect Ethereum to Near and move an ERC20 token, lock it up in the Ethereum side, and then verify that it's locked on the Near side, mint some tokens that are equivalent that you can do whatever you want with on Near, lower transaction fees, higher throughput, better account system, easier to understand, et cetera, and then once you're done with whatever it is that you want to do, you can move those tokens back over to Ethereum by unlocking them. You I guess lock them or burn them on the Near side, and then you would unlock on the Ethereum side. So that's what that demo is about. It's in progress and should be ready in a couple of weeks. But the FT and the NFT links just above, Nikhil, for your benefit, I think you asked that question, are implementations of the non-fungible token standard and the fungible token standard on Near. And those have slightly different numbers. So ERC20 is NEP21, and those are a little bit different on the Near side because there are considerations with the way Near works, where to make those standards work on Near, we had to kind of simplify some things and switch things up. We also don't have events on Near where you have events on Ethereum, for example. And so there's going to be some trade-offs there in the design of the contracts. So ERC20, for example, has events that are raised throughout. We don't do that, but we can log. We can write to the log, or we can store in a kind of a collection of events that we just call them events. But they're things that happen that we just write to the chain. But there's no event emitting model. There's no way to like emit events and listen to them as you would in Near in Ethereum. Sorry. Anyway, so. Maybe that answers your question. Looks like a thumbs up. If you want to dig into that a little bit more, we can. But given that I'm moving, not as quick as I had thought, we might be a little bit tight on time to actually deploy these things. But they're there, the NFT and NFT contracts, and we can certainly clone them and take a look at them if you like. I think it might be useful, given everything that we've seen, to kind of go back to the slides, unless anybody has any other preferences, and just spend the last 10-15 minutes kind of finishing up the slides. A little bit out of order, but again, this would be the fourth recording of this presentation. So if you want to see the original order of these slides, you can just look at the other three recordings. All right, let me just share my screen again and finish up with these slides. Okay, so just going right back to the top here, there's links to the other three recordings right there on the first slide, and the intent of Near 101 is to be an intro for web devs. So we've gone through the agenda. This is the Rainbow Bridge. Very briefly on this thing, I'll tell you what I know about it, and you can certainly read more about it and ask about it on Discord. But basically, you've got Near protocol on one side, Ethereum on the other side, and what happens at the lowest level, even though it's at the top of this diagram, at the lowest level, there is a piece of software, a contract that's written in Solidity called a Near Light client that receives from some external program that's monitoring Near and polling Near to find out what's going on, and where's what block height are we at now, and what block height are we at now, sending the headers. This relay sends the headers from Near, it's maybe written Node or whatever your favorite language is, sends the headers over to this Near Light client so that this Light client can basically track the progress of the Near blockchain. The same thing happens on the Near side. There's an Ethereum Light client written in Rust or assembly script. It's actually written in Rust. And it's receiving from the Ethereum to Near relay, again, this other program written in whatever language you want that's just running on some server somewhere, a cron job, that's listening to Ethereum and just passing Ethereum headers over to this contract that is basically monitoring the progress of the Ethereum blockchain, but it lives on Near. So these light clients are basically watching the other chain. So now Ethereum has a contract that knows about Near, and Near has a contract that knows about Ethereum. On top of these, we build another contract that is called a prover, and this prover can prove whatever you want to prove about the other chain. So the Ethereum prover proves things about the Ethereum blockchain, the Near prover proves things about the Near blockchain, and we've chosen as an initial implementation on the Near side of the bridge watching Ethereum to prove that an event has occurred on the blockchain and been recorded. So the Ethereum prover proves that an event has occurred on the Ethereum blockchain. The Near prover proves that a transaction has been executed on Near. So Near, whatever's happening on Near is visible to the Ethereum side of the bridge with the ability to prove that a transaction has happened on Near, but you're in an Ethereum context. The opposite is true on the Near side. You can prove that an event has occurred in Ethereum, but you're in a Near context. On top of that, you can build things like a mintable fungible token on the Near side and a token locker on the Ethereum side. So then here we are with the people in the middle. Somebody, this is the same person, is looking at, say, their wallet. They decide to lock some tokens on the Ethereum side, whatever the ERC20 tokens are, and then that locker then is a contract sitting on Ethereum, which gets recorded on the chain, eventually relayed, evidence of the event of that locking is relayed to the Ethereum Lite client on the Near side, proven by the prover, because the mintable fungible token is checking the prover to see, has this event occurred? When it has, it mints tokens and then renders them in the wallet. So the wallet, you can imagine, is calling the token locker to lock tokens, and then checking the mintable fungible token locker, the mintable fungible token regularly to say, hey, did you notice that these tokens were locked on the Ethereum side? As soon as you do, go ahead and mint the tokens on the Near side. So this is how you move things across the bridge. And of course, you can implement other provers. That's a non-trivial task. Or you can build contracts on top of the existing provers, which is far easier. The easiest thing to do is to use the existing mintable fungible token and token locker and just, lock some other ERC20 compatible token, because basically 90% of the work is done for you. So that gives you a sense of the extensibility of the contract. In terms of dissecting an application, here's a demo application called the Guestbook. And this is available at near.dev. You grab this application, you deploy it. This is what it looks like when it shows up, this bit on the right-hand side here. You can put a message in and then put an optional donation. When you put a donation, you've got to sign that message because you're actually sending money, and it requires some extra authorization from your account. This is a view you can get where we're actually watching the state of the contract and the budget of the two accounts. It's a little bit small to see on my screen probably, but you can zoom in if you're looking directly at the slides. And so if you set this up, and here the instructions, here's how, is a link right here. You can follow the instructions to actually set this up to watch it. As you record messages, you'll see the state change in the contract. It's actually quite nice, and you can decode this using some base64 decoder online. And I walked through this demo a couple of times in the previous recordings. The files themselves look like this. We've seen these files. We were playing with these and diving in. If we want to take a look at the details in this folder here, we would just see the JSON file with some private keys in it. In fact, I remember now, Paul, I don't think I answered your question about where the other keys are stored. They're stored in a location in your home directory, which is near credentials. And you can see here, this is the name of the network. So BetaNet, TestNet is also called default, local, and then TestNet here as well. And so you can see these are the dev ones that I've been playing with, and then these are some other keys. They're all stored here in your near credentials. These are all accounts. You can check them by checking using the near keys function. That's a function of the CLI here. sorry, the formatting's terrible on this. Sorry about that. It's this command right here. So near keys, and you can check the keys, or you can check the state of the account, and so on. This is all part of the near CLI. Okay, so that's the other location that we were talking about. And then this, the rest of these slides just walk through, the data model for this. We can store data and serialize it. There's a couple of details there. Again, if you're curious about this, you can watch the recording of the previous ones. There's the main contract file and assembly script adding a message and getting the messages. There's a message limit there. The same config file, pretty much boilerplate. Very similar index file. Different messages here being tied in, get message and add message, as opposed to the demo app that's built by a Create Near app. And then this is a React application. Again, a lot of this stuff is boilerplate, the sign-in stuff, and then calling these functions. In general, there's two paths for development on Near, which wouldn't be surprising if you're familiar with blockchain, but basically you build contracts and then you build the user experience on top of those contracts. And so these are the two parts that the other recordings go into. You've seen this before. This is what a transaction looks like in terms of its steps. And then this is the part that your application is dealing with, the highlighted yellow part. In terms of the platform, we saw the Explorer. Although it was a bit sluggish, we didn't actually get to load it. It looks like this when you do load it. We saw the wallet. This is where the keys are. We saw that. We took a brief look at the Near CLI. The Near API.js is the client-side library that you use to connect with Near. We saw what the code looks like there. That's where we can set up the JavaScript object that, called contract and attach methods to it. There's a bunch of things you can do with that. If you're familiar with Ethereum, it's similar to the Ethers library, actually, the implementation. The difference between client and server side is very small. You're basically picking where your keys go. If it's a browser, it's browser local storage. If it's a file system, it's, you saw those files on my file system, but everything else is basically the same. And we use all this stuff that you're using for your application. So it's the same technology, the same libraries that we use internally to build out our examples, to build out Explorer, to build out Wallet, to build out the CLI. It's all the same stuff that you would use to build out your decentralized application. Near API.js communicating through this RPC interface that hits the blockchain layer. So there's really no difference between the quality of the applications that you can build on Near and the ones that we can build. It's all the same stuff, and it's all open source. And then a little bit more about Near SDK-AS. You saw some of this. You saw some of the Rust side of things. We talked about accounts, transactions, and state. And so all of this we covered already, and we walked through Create Near app as well. The only thing that we didn't cover here were these questions. So if you're curious, if you want to push a little bit, there's a slide in here. Where do we set up a connection to Near? There's a hint. You can try and ignore that hint and actually look for this yourself. Where do we set up this connection? Where do we log into Near Wallet? Which lines of code wire up the contract to the JS context? And then maybe trying to reverse engineer the greeting, before you write on chain it to reverse the greeting string. You might do it there. You might do it in the client. It's up to you. But answering these questions for yourself will force you to look at key parts of the code. And if you just ignore the light colored text in the hint, that'll challenge you a little bit more. So the last thing we didn't talk about is cross-contract calls. And this is where we get into the scalability of Near. Basically, you can spread your calls across multiple accounts. And remember, an account is synonymous with a contract in Near. And we can think of this as two perspectives, external calls and internal calls, although it's debatable whether or not this is a good way to think of it. I'm wide open to feedback. And then two types of calls, batch calls and promise calls. So in terms of the sort of the mental model that you might have of this, there's the context of the call, like where are you actually making it from? Is it internal or external? And then the type of the call, is it a batch call where you're batching a couple of actions together and sending them to the network? Or is it a promise where you're kind of sending a message to do something with a contract, calling a method asynchronously, and then kind of getting either a callback or resolving a promise to get the answer back? So that's kind of the difference here. And just to look at this, all the purple stickers are contracts, all the blue are transactions, all the green are actions that are composed into those. And so we'll see the code in just a second here, but from inside of my contract code, I'm writing a Rust contract or I'm writing an assembly script contract, I'm internal here. I might decide that I want to invoke a transaction on another account, or even create a new contract. So the transaction might be create account, deploy a contract to it, fund it, and then invoke a method on it, add a key, whatever. And so from inside of my code, I can create a new account. I can deploy a contract to that account, and so on. So that would be a batch cross-contract call. It's a batch of actions, a collection of actions that I'm calling from inside the contract code itself. I can do a similar batch call from outside by composing some actions together. So moving up here, from a web page context, I can build a transaction by bringing together some actions, and then I can send that to the network. And so that would be what we might refer to as an external batch, as opposed to internal batch call. On the promise side of things, I'm inside of my contract code, so internal, and I want to invoke a method on an existing contract, right? So I can do the same thing with the internal batch, but the promise allows me to do things like attaching a callback, for example. And so that would actually send out that call, and then I might have another method on myself that gets called when I come back. So I make a call, do something, and then whenever you're done with that, do the other thing. That's also a method that I have now. So do something is a method you have. The other thing is a method I have. Do something is a method you have. Do the other thing is a method I have. And so I would call do something. You do the other thing. When you're done with that, that would be the promise. And then, of course, this goes without saying, you can always compose promises in JavaScript just for the symmetry of this conversation. Typical promises that you would use in a JavaScript context, you can certainly do in this context as well. There's nothing near specific about this at all, but it does give you a sense of the symmetry of these internal and external promises. So that's the reason for including that. Here's what they look like. This is an external batch call, and so I'm in a JavaScript context importing from near API.js. The idea of this, actions actually is a better name for this, but it's transactions. And then I can add a deploy contract, a function call, add these to a collection, and then actually sign and send that collection, that transaction basically. I can sign and send that out to the network. Or I can do these promise calls from outside in JavaScript. Again, this is just plain JavaScript. Internally, I can do a batch call where I, from inside the context of AssemblyScript or Rust, I can decide to create an account, transfer some tokens to it, add a full access key, then create another account. So the banana, peel the banana, eat the banana. I can make all of these contracts, even deploy contracts to them, contract code to them, and then invoke those methods. And I can also here call a promise, invoke a function on another account, attaching some gas to make sure that it completes, and include a callback. So peel the banana, use fingers as the method, peel the banana as the account, and then eat the banana, use face as the method. Okay. And so here, just kind of aligning these code samples on that grid. And then there's some testing to know about. We looked at testing briefly, but with AssemblyScript, you've got this unit testing using Aspect. With Rust, it's built in. There's also simulation testing that's included, either from a VM tool that runs right from the command line or using a runtime API. And then integration testing, what you would expect, just kind of testing the entire application at the very highest levels. And so this is kind of the process that you might move through. Here's what the unit tests look like, pretty standard stuff. And so here's what the simulation tests look like with the near VM, with the runtime VM. You can compose contract calls and do a bunch of good stuff there. And then integration tests at a very high level would look like the kind of tests you would expect to see, with something like Jasmine or Mocha or whatever. All right. So those are the slides, and we're just 5 minutes out. Anything else that we want to discuss right now? Any questions that we want to cover?
I'm eagerly watching chat. Nothing.
Yep, doesn't.
Personally, that was clear enough for somebody who doesn't have a lot of in-depth coding understanding, right? So I was able to put the pieces together, so it was nice. So
awesome.
Thank you.
Yeah. Oh, that's great. I'm really glad. Actually, if you don't mind, just with the last 5 minutes here, I'll make another survey visible, just to see if this workshop was worth your time. If you could do me the favor of just giving me feedback. Was it sort of the worst use of your time? That would be a disaster, but I won't take it personally, I promise. Or was it the best use of your time? And if it wasn't the best use of your time, if you have some suggestions for improvement, I would really, I'm wide open to hear that. What can we do to make this better? What's the right next iteration? All ears for that if you want to post it here, or if you'd prefer to do it in some other format, submitting feedback somehow through Discord or Telegram or through a different account. If you don't want to identify yourself, that's fine.
I can link an anonymous type form real fast if you want, Sherif, or something like that. Would that be helpful?
Yeah, I mean, that's fine. I think that the challenge there is that whatever we post in here is going to be open permanently with the recording. And so, I don't know if we want people to be filling out that form that haven't seen the workshop later, but sure, we could do that. People will watch the recording, maybe they could fill that out. So if it's easy enough, I think you can just post it in here anytime. Really.
I gotcha.
Yeah, no worries. Okay, any other questions or comments? Anything else that we want to cover right now? If not, this was a pleasure. Thank you so much for your attention. Really appreciate it. Again, there's 3 recordings. This is the 4th of this workshop. We're going to continue to improve this and tighten it up. And so I think we got some good variants today with some of these questions, so we can include those next time. If there's anything else that you think of, we're wide open. Discord, Telegram, whatever it is. We love the feedback. Just going to mute you, Ash. Okay, anything else that we want to cover? I'll give it a couple of minutes here. We're just 5 minutes before 9:30. Oh, nice. Okay, that's great. Thanks, Ash, for doing that. So, Paul, the best place to get started with writing for the bridge would be this URL. I included it earlier. Yeah, it looks like I've already posted this message. Best intro to building on the bridge. I think if I change the text, it'll let me post it. So that's the best intro there, and it's a demo. Awesome, Scott. That's great. We look forward to having you, man. So Paul, hopefully that helps. That's a demo. I don't know if it's fully working right now, but it's in progress and should be ready shortly. Certainly worth taking a look at. You'll learn a lot just by digging through that code, and that would be kind of the most kind of basic application that you could build that deploys a new token across the bridge. So that's what that example is for. All right, any other questions, any other comments, anything else that we want to dig into? All right. Okay, well, thank you so much for your attention. Really appreciate it. This was a great pleasure. Thanks, Ash, for joining. Awesome help. Really appreciate it. Appreciate the questions and the facilitation. Awesome. Thank you, Josh. Okay, everybody, have a great one. Happy hacking with Nir, and look forward to seeing what you built. Yeah. All right. See ya.